Pin the data block with a paperclip and open Converge Station function by double-clicking. Scroll down to our function block. Now pin this window and double-click on the conveyor function block. In the block's interface, scroll down to the in-out section. Type in conveyor interface and press enter. Change its data type to type conveyor control. Because we modified function block's interface, it is highlighted in the call environment by red color. Let's right-click on the call of the block and choose Update Block Call. Press OK. And as you can see, the new conveyor interface variable has appeared at the bottom of the block. Let's do the same for the other two calls of the conveyor function block. Update block call. Press OK. Update block call. Press OK. Because the new variable in the in-out interface is of type conveyor control, it automatically populated all the elements of this type. We will now start replacing some of the old elements of the conveyor function block to the new interface that will feed information directly from the function block into the HMI screens. In network 1, we have two elements that we will replace: target reached and timeout. Currently, they are normal outputs of the block, but we want to feed this information into the conveyor interface in-out element that will be connected to HMI screens. Let's start by removing the old elements. Highlight Out Target Reached, and on your keyboard, press the following combination of the buttons: Ctrl, Shift, and D. D stands for definition. So this combination automatically highlighted our Out Target Reached definition in the block's interface. Let's do that again. Ctrl, Shift, D. And as you can see, Out Target Reached is highlighted. Click on the little tag and click on Delete on your keyboard. Because we deleted this output, now it is highlighted in the code by a red squiggly line. And of course, the call of the block is highlighted in red because we changed the interface. Now let's find Out Timeout. Highlight it and press Ctrl, Shift, and D again. And it shows us exactly where it is defined. Click on the tag and delete. Now replace the old, now non-existent elements with the new elements from the conveyor interface. As usual, use drag and drop. Target reached and conveyor timeout. Scroll down to network number 2. Start by replacing target reached. And let's use the same method to remove all the elements of the counter app. Highlight, definition, delete. Highlight, Ctrl Shift D, delete. Highlight, definition, delete. And let's insert the new elements. Command to reset the counter. Counter's preset value. And counter's current value. Scroll down to network 6. Replace the already deleted output timeout with the new interface conveyor timeout. Remove the input timeout. Ctrl-Shift-N-D, highlight the input, delete, and drag and drop timeout preset time in that place. Now in network 7, we will do some sensor mapping for the HMI. Insert normally opened contact and a coil. Click before the contact, open new branch, and again normally opened contact and a coil. For the coils, use the new conveyor interface sensor signals. Sensor 1, sensor 2. So we will provide to the HMI screens information whether sensor 1 or 2 is being triggered. We will acquire this information directly from the function block's inputs. Entry peg, it will be the sensor 1, and exit peg will be the sensor 2. So what we are doing here, we are directly mapping inputs of the block to the conveyor interface, only for HMI information purposes. Okay, now it's time to update the call of the block again. Right-click on the call and choose Update Block Call. But this time, let's have a closer look at the changes we are implementing. Please look how much cleaner the block's interface is now. We removed 3 outputs and 3 inputs. All of them are now inserted by a single interface that contained all of this information bundled together by the means of our PLC data type. Press OK. And do the same action for the other 2 function block calls. Right-click, Update Block Call. And conveyor number 3, right-click, Update Block Call. OK. Before we continue, let's once again have a look at the blocks interface. So we have a single variable of data type conveyor control, which holds inside all the elements we created in that type. This is all considered a single variable. Conveyor interface, data type conveyor control. Let's pull up the data block again. And let's go back to our array. So now we have 3 array elements, each of them holding exactly the same elements as the conveyor interface because we used exactly the same PLC data type. Let's have a look at the interface. If we click here and wait a little bit, we get the information that this variable only accepts type conveyor control variables. It also shows us that is a type of in-out. Just to show you, let's try to assign a Boolean variable. And as expected, it is highlighted in red. It is because in this place, the block is not expecting a Boolean variable. It is expecting a variable of data type conveyor control. So let's insert the correct variable. We will insert element 1 of the conveyor control array. As you can see, this element was easily accepted. It is because this element, just like the other 2 elements of the array, are of data type conveyor control, just like our conveyor interface. Let's do the same for the other 2 conveyors. Conveyor number 2 will receive element number 2 of the array. And conveyor number 3 will receive third element number 3 of the array. Now, looking at the conveyor numbers and our arrays numbering and indexing, now you can see what was mentioned in the previous lesson. It just makes much more sense and is much more natural to have this array numbered from 1 to 3 rather than from 0 to 2. If we used the numbering from 0 to 2, then conveyor number 1 would receive element 0 of the array, conveyor number 2 would receive element 1 of the array, and conveyor number 3 would receive element 2 of the array, which is just much less natural than the method we used.